Hi, so I'm trying to show you how to use IBM SPSS for tutorial on inferential statistics, okay, which is going to cover on t-test and also Anova. Okay, first let's see, try to open up the file. Okay, go to file, open data. So I'm looking for SAV data, the mset.sav that we have shared. Okay, so I saved the file in this folder, so I'm going to take this file empsat.sav. Okay, we have shared this in Spectrum. Yes. Okay, so as you can see, data view is here, down here, and then you can see variable view. So in variable view is where you have to put in all your questions from the survey or whatever that you're going to do for the analysis, right? So you can transfer them here, okay, under the name. So in this case, there are 21 questions here, okay, altogether 25, right? The 25 different variables which are stored here, okay, and what that name actually reflects, you can write under label. For example, hours here referring to how many hours a week on average does your employer expect you to work, right? So these are the various questions that you also can transfer from your survey when you are transferring them into SPSS, if you are using SPSS, or you can use other tools, right, as we mentioned before. And okay, so getting back to tutorial 1, sorry, not tutorial 1, I mean it's tutorial on inferential statistic. Okay, as you can see, the first question is, what is the frequency for the number of hours worked for the employees? Okay, what is the frequency of number of hours worked for the employees, right? Okay, let's see. Okay, for that question 1, as you can see here on top here, all right, you can see this file, edit, view, data, transform, analyze, graphs, utilities, extension, window, and help. Okay, most of the time throughout the tutorial we'll be using analyze, okay, or graph, all right, but usually even within analyze you actually have options to build your charts. Okay, all right, so now frequency, mean, median, standard deviation, what can you say about these statistics? What are they actually, right? If you still remember, these can be categorized as descriptive statistics. Okay, so for the first question, what is the frequency for the number of hours worked? You can go to descriptive statistics under analyze tab, go to frequency, okay, and then for example I clear this first. All right, so this is where all the questions are. Okay, whatever which are in your label just now in under variable view can be viewed here. So I'm going to choose how many hours. So the question is the frequency for number of hours worked by the employee. So it should be the first one, right? How many hours a week on average does your employer expect you to work, right? Okay, so I choose that, click here, and then you can look at this. You can build chart at the same time if you want for that particular variable. Okay, let's see what do you have at statistics. Okay, you can actually choose what you want to see in the results box. Do you want to see central tendency like mean, median, mode, right? Or do you want to see the quartiles or percentile, standard deviation, variance, range, minimum, maximum? All these can be ticked here, and then you just continue. Okay, for now I just leave it empty, right? You can even decide to build a chart, a bar chart or pie chart or histogram, right? Okay, for example, just say I leave it as bar chart. Okay, I leave this as frequency. I want the chart values to appear in terms of frequency, all right? So right, continue. Okay, so the result window will open up. As you can see, this is the answer for it. Okay, so this is in the form of table. As you can see, these are the 4 different choices which exist in the variable view just now, right? So for that particular question, they were all these 4 choices, which is 35 hours or less, 36 to 40 hours, 41 to 50 hours, 51 or more hours. and this is the frequency for each, and this is the total. Okay, if I did not choose the chart just now, this will be empty. Okay, but because I chose to plot a histogram chart for this particular variable, so I can see this now, right? And you can see how it plotted by frequency because I chose to put frequency, not percentage. Okay, and then this is the values, right? I mean, this is the category in that particular variable. Okay, so simple. Okay, so I just wanted to show you for that question one. If you see here, right, the label, right, the label shows that particular question. If you go to values under the variable view, you will see, you click the three dots here, you will see the three different categories that is under that particular question, how many hours a week. So I'm sure even in your survey, you have questions like this, right? You have one question with few choices. So this is how you put it in. Give a value 1, for example, especially the scale kind of questions, right? You can put 0, what will be the label? 1, what will be the label? Until maybe just say your scale is 0 to 5. Okay, value 5, what is the label? And then press OK. So these values will be stored here, right? So these will be values will be used when they are computed for your stats, right? We move on to question 2. Okay, question 2 here says, draw any chart to show how long the employees have worked for the for the employer, right? So it's simple. So what do? I go to the same analyze, descriptive, frequency. Okay, how long? The question is how long? Draw a chart for how long employees have worked for the employer. So should be this question. I remove this first, or I just put reset. How long have you worked for this employer? I choose that, and I go to chart. I choose bar chart. For example, you can draw any chart, but just say I choose bar chart. I want to put in frequency. Continue. Or can I do more? Just say bar chart, or cannot at one time one. Okay, just say I do pie chart with percentage. Let's see what happens. Okay. Okay. So now I have a pie chart. Okay. With, of course, percentage. All right. So what happens if I choose analyze, descriptive, analyze, descriptive, frequency, the same thing, but I draw bar chart now, frequency. Okay, so I get this chart now. Okay, so as you can see, the category here, less than 1 year, 1 to 3 years, 4 to 6, 7 or more years. So the same thing you will see in the values column under the variable view. Okay, we move on to the next. Okay, the next question says, provide the mean and standard deviation for the statements below. Based on your results, what can you conclude? Write a short paragraph of your conclusion to be presented to your boss. Right? So the 5 questions here are given. I am satisfied with the communication between management and employees. I am challenged and interested in my work, and so on. Right? So this question can be found in the data set that we have given to you. Okay. All right. Let's go to IBM. Okay. Now we need to see the central tendencies, right? Basically, we are going to go through what is the mean and standard deviation. So let's try analyze, descriptive statistics. We can go to frequency as well. Okay. And then, okay, reset first. Okay, let's choose the questions. I'm satisfied with the communication. I choose that. I am challenged. I choose that. My opinions, where is that? Okay, so my opinion, I choose that. The senior management team offers. Senior management team offers. I choose that. And the company culture, I choose that. Okay, so I can go to statistics. Okay, what I want to see? I want to see the mean and I want to see the standard deviation. Okay, I click the mean and standard deviation and then I continue. Okay, so I will get a statistics here which shows the 5 questions that we chose just now. Okay, and we can see what is the mean for each. You can see this row is mean and this row is standard deviation. Okay, right, these are some additional frequency tables. Okay, all right. So write a short paragraph on your conclusion. You can just write a conclusion based on this mean, you know. So for example, if look at what does 1 mean and what the value towards 5 means. Okay, let's have a look at the values for it. Okay, I'm satisfied with communication between management and employees. Okay, I'm going to go to that question. I'm satisfied with the communication between management and employees. I go to the values and I just want to have a look at what does it mean. What does 0 mean and what does 5 mean? 0 means NA or don't know. 5 means strongly agree. So based on this, I can make some kind of conclusion, right? That means when your standard deviation was more to 4 point something, that means most of the respondents actually strongly agree. It is towards strongly agree on that particular satisfaction question on communication between management and employee. So that's how you make conclusions, right? Look back at these values. What does that 4 point something means, right? Of course, you need to know what is 4 point something. How you look is go back to these values to understand what is 4 point something, right? So you know 4 point something is between these 4 and strongly agree. Okay. Okay, next we go to question 4. So question 4, what it says is there a significant gender difference for the overall satisfaction of job? So now, significant gender difference. This sounds like t-test, right? So you want to know if there is any significant difference between two variables. So what are the variables? One is gender, another one is the overall satisfaction of the job. So write the hypothesis and then test them with an appropriate test. Provide all the necessary values. Okay. Okay, so for this question, when you want to check the significance, okay, relationship between two variables, I would use t-test. Okay, so in this case, it is not it is not a one tail. We are going to use here compare means, okay, for to do t-test here, and it is not, as I mentioned just now, not a one sample t-test, but it is a two sample t-test, which is we are going to use independent sample t-test. Okay, one sample t-test you use when you are comparing a mean with of a population and a mean of a sample taken from the population. But in this case, we are comparing two different means of different variables, but they are independent. Okay, they are not paired. So it's independent sample t-test. So go to compare means, independent sample t-test, and then you will see this window again. So choose the question. Test variable is the one that you are going to test against a particular variable. So in this case, is there a significant gender difference for the overall satisfaction? Okay, so here the grouping is in gender, right? The one that you're testing is the overall satisfaction of the job, whether that variable of overall satisfaction is different when the gender is different. Okay, so the test will be the grouping variable here will be the gender. So first thing, look for the question which is overall satisfaction. Okay, where is the overall satisfaction, right? So down here, overall, how satisfied are you with your job? I choose under test variable, and then I choose gender. What is your gender as my grouping variable? So if you realize I can't okay yet, right? I have to go and define group. So what are basically the defined group here? So here basically I have to go and refer back to the variable view to see what is how the values are stored for grouping of gender. Okay, so I go back to the data. Okay, what is gender? Go to values. If I click the three dots, okay, male is 1, female is 2. Okay, so the same thing I'll put here. Group 1, just say male. Group 2, female. You can put the other way around as well. Okay, continue, and I just put okay. Right, so now I get the t-test results. Okay, so you can see this window is the t-test results. So it shows what is gender, how many of them in male, female, what was the mean, standard deviation. Okay, by default this comes out. Okay, where do you have to look for your p-value? Okay, if you still remember in my lectures, I did mention that at the end of the day, when you generate a t-test results, just look for the p-value which you can match it or compare with the critical value Okay, critical value is based on, is basically the alpha value that is generated based on confidence level. Okay, for example, if your confidence level that you set is 95%, so your p value will be your critical value or alpha value will be 0.05. Okay, so if you can see here, this is where you look for the p value. Significance two-tailed test. So what is the p value? If I ask you what is the p value, the p value here is 0.362. So how do I conclude these results? Is it considered significant or not with gender? Okay, so I have the answer here. Okay, you can write your null hypothesis like this. There is no significant difference between the gender, okay, and the overall satisfaction of the job. Okay, and the null hypothesis, and the alternative hypothesis will be there is a significant difference between the gender and overall satisfaction of the job. Okay, so now your t-test gave the value of 0.362. Okay, so 0.362 is lesser than, bigger than 0.005, because if you take your confidence level as 95%, okay, and take my alpha value or critical value, we can call it as 0.05. Okay, so in this case, because 0.362 is bigger than 0.05, we cannot reject the null hypothesis. Okay, so we accept the null hypothesis. So what does the null hypothesis say? Null hypothesis say there is no significant difference between the gender and the overall satisfaction of the job. Okay, very simple as that. All right, so if I ask you at which p value, at which confidence level do you think the results will be significant? Okay, for the results to be significant, you have to reject the null hypothesis, right? So to reject the null hypothesis, your p value must be smaller than 0.05. But currently the p value is 0.362. But if my confidence level I set as, just say 60%, then my alpha value will be 0.4. Correct? In this situation, if this is the situation, then your p now, okay, is smaller than your alpha. In this case, we can reject the null hypothesis, okay, and accept alternative hypothesis, right? But as you can see, this confidence level is very, very low, right? People don't really set this much of confidence level. So basically what it tells you is when you set your confidence level lower, it is much easier to reject a null hypothesis, right? So you can see how people can manipulate results, right? You can say that it is significant, but of course, if your confidence level is so low, that means out of 100 tests, 60% only might be true and 40% might be because of chance, right? So it is not that reliable, okay, when you do this kind of test with a very low confidence level. Okay, so I just wanted to show you the difference. Okay, now we move on to question 5. Okay, I just realized question 5 is very similar to question 4. Okay, I think you would be able to try this, okay, the similar way, but now you choose these 3 different questions, okay, and do the independent t-test, and then look at the p-value and see whether it is lesser than 0.05, and if it is lesser than 0.05, then you can reject the null hypothesis and you can make conclusions that there is a significant difference. But if you cannot reject the null hypothesis, that means there is no significant difference. So you should get only the last result is significant, which is the third one. Okay, the first two are not significant. That means you cannot reject the null hypothesis to a particular confidence level, for example 95% of confidence level. Okay, so this one will give you a significant difference. That means you can reject null hypothesis for at 95% confidence level. Okay, so I'll move on to question 6. Okay, we continue with question 6. Sorry, had to end the previous video, technical issues. Okay, so question 6 shows that perform a test to see if there is a difference between those 18 to 24 and those who are more than 55 when it comes to their overall job satisfaction. So if you can see here, job satisfaction is the variable we are going to test, and then the two groups which are being tested here is the age group, which is 18 to 24 and 55. Okay, so if I look at the data, you see in the age group there are actually 5 different groups here. Okay, but we are only going to look at 18 to 24 and 55, which is the value 1 and value 5. We need it later for the t-test. Okay, so go to analyze, compare means, independent sample t-test, and then you go to how satisfied are you with the job as a test variable, and then you choose age group as your grouping variable, define group 1 and 5, right, based on the two different age group that we have referred just now in the data variable, in the variable view. Continue. Okay, right. So if you can see here, to find out where is a p-value, just look at here, significance to tail column here. So you can see, so if you know the variance is equal, then you take this value, but most of the time we don't know what is the variance, or if you did not compute the variance, you can take this value, which is 0.007. So regardless whichever value we take here, both are actually less than 0.05 for confidence level of 95%. So in this case, we can reject the null hypothesis, which says that there is a difference between those that says that there is no difference between those 18 to 24 and more than 55 when it comes to their overall job satisfaction. Okay, so we can reject that and accept that there is a difference. But you must understand that in this data, we are not saying which one actually has a better, I mean, which group of people were more satisfied. We don't know, right? At this one, we are just checking whether the mean is equal or not. Okay, referring to this anyway. Okay, so yeah, so just take this value because it's lesser than null hypothesis, which is there is no difference, so you reject the null hypothesis, and then you accept that there is a difference between the two different groups. So question 7, what does the question 7 says? Do the same, but now use the statement in 5. Okay, but for the age group of 6. So we are still using the same age group, but now we are using these 3 questions. Okay, simple, just repeat the same way. Okay, yep, let's see, sorry. Analyze, compare means, independent t-test, reset. Okay, let me choose the questions now. How satisfied are you with the flexibility? Chosen. How satisfied are you with the total compensation? Chosen. And how do you feel your compensation? Chosen. The age group, defined group 1 and 5, because the same age group. Okay, so if you see, I get these results. So from these results, what can you say? So you look at for p-value here, right? So if your confidence level is 95%, your critical value or alpha value is 0.05. So which are significant? Observe. Okay, so if you can see, this is significant, less than 0.05. This is significant, less than 0.05. This is not. Okay, so the last one is not significant. That means you cannot reject the null hypothesis. So we don't know or we don't have proof through the data that it shows that there is a difference between the two groups. Okay, so only for these 2 questions, it says that there is a difference in terms of satisfaction for these 2 different groups of people, right? 18 to 24 and more than 55. Okay, but we don't know who are more satisfied, as I mentioned just now. For that, you must do a multiple comparison test, okay, which we will discuss later when you go to Anova. Okay, so that is for question 7, right? This is 7, so it's got, yeah, right? The first one is 0.07, 0.04, and the last one is not significant. Okay, so I'll move on to tutorial 8, yes, but the second part, which is Anova. Hi, so now I'm going to continue on the tutorial for inferential statistics, the second part, which is on Anova. Okay, so as if you can reflect back from our lecture, so we use Anova when we want to compare more than 2 means, right, to see if any significant difference exists between more than 2 means, right? So 2 and 3 and above, you can use Anova, right? So the first question, let's look at the first one. Perform a one-way Anova to test if the means of age are significantly different for the following statements. So these are the various statements which are given, which is based on the data, the variable view, if you can see, right? And then they say that we look at means of age and also state and hypothesis. Okay, let's look at the variable view first. If you look at age, see what are the groups of age they have, we did just now. Okay, so these are the 5 different groups of age. So we want to look at if the mean for each of these group of age is significantly different, right, for the various statements that are given in question number 1. Okay, so first things first, maybe I'll just show you an example how do you write an hypothesis. Okay, so this is a sample of an hypothesis I wrote for number 1. Okay, you can write in symbol or you can write in terms of description like this, right, in a sentence. For example, for the question number 1a, I wrote the null hypothesis as there is no significant difference between different age groups and the satisfaction with communication between management and employees. Okay, and then the alternative will be there is a significant difference between different age groups and the satisfaction with communications between management and employees. Okay, so using this, you can start thinking how you can do similar hypothesis statements for question 1b until j. Okay, based on that, later when you do the Anova test, looking at the significant value or the p-value, you can decide whether to accept or reject the null hypothesis for a critical value of 0.05, assuming that the confidence level is 95%. So going back to SPSS, okay, what do we do for question number 1? I'm using the same data set, empsat.sav, Okay, I go to analyze, I go to compare means, I go to Way Anova. Okay, I reset first because there's so many questions actually have to select here, so I'll do one by one. So question 1A, if you see first one, I am satisfied with communication, I add on. I am challenged, I add on. I feel adequately, add on. The relationship I have with my manager, I add on. The organization shares, management does a good job, and then I have my opinions in the senior management I'm in, and the last one, the company culture problem, ethical behavior in. Those are all dependent lists. Okay, so now what am I going to compare with? Right, so in this case it's going to be based on age, right? So age, what is my age group? In which age group? Okay, choose that as a factor. So the first question does not require us to do any changes. You can just press OK and then you can see the value. Okay, so when you click OK, this is the results that will come out. As you can see, between groups, DF is 4. Okay, DS is 4 because degree of freedom is n minus 1. N is the total number of groups. So in this case, the age has how many groups? 5 groups, right? So 5 minus 1 here is 4. That is why you see between groups, it is 4. Okay, all right. So for example, here, A to J, right? These are all the questions A to J. So which one is significantly different? Right? So you have to look at the p-value. So you look at p-value at this significance level value here, SIG. So which one is significant? Only question number 2, which is I am challenged and interested in my work. Only this gives a value of less than 0.05. Okay, so only for hypothesis of B, 1B, you can reject the null hypothesis. Okay, so when you reject the null hypothesis, the alternative says that there is a significant difference in terms of age. Sorry, let me read again. I'm confused. Okay, you can say that there is no significant difference between different age groups and the challenges. Sorry, I am challenged and interested in my work, right? Okay, in terms of the age groups and the perception of the worker in terms of whether the work is challenging and interesting or something like that. You have to reword a bit, all right? Because it is asking about I am challenged and interested in my work. So you are trying to say in null hypothesis that there is no significant difference between the age groups of the employees who said that they are challenged and interested in their work. Okay, so you write a logical statement for that. Okay, and the alternative will be there is significant difference, okay, between the different age group in terms of employees who are challenged and interested in their work, right? So I'm sure you can write a better statement than I did. Okay, so yeah, so basically that's how it works. So in that case, now null hypothesis can be rejected because the p-value is lesser than 0.05, right? And then you accept the the alternative that there is a significant difference. Okay, so only this shows a p-value of less than 0.05. Okay, so as we explain this to you, I also hope that once you have put in your data into your SPSS or any tool, right, and then when you generate p-values, you are able to also explain the results, right, in terms of understanding relationship between two variables for your group project. Okay, so number 1 is done. So number 2 basically says perform a two-key post hoc analysis. Okay, what is a two-key post hoc analysis? I would have mentioned in the lecture. Okay, so at question 1, the Anova test basically says that whether it is significantly different or it is not significantly different, right? So whether you accept it is different or not, right? The means are different or not. But you won't know which group in the age factor actually causing the difference. Okay, for example, if you find that one of the statements in number 1 is significant different, right, that means where you reject null hypothesis, what actually causing that? There are so many age groups, right, inside. How do you know which age group is actually causing such results where you have to reject the null hypothesis and you have to accept that yes, there is a difference in terms of age, right? There might be certain factors which are strong in terms of resulting that particular rejection in null hypothesis. So you can do that by using Tukey, right? So Tukey is just another function. Okay, I close this one. So say I go to analyze, my results will be still there, but I can just add on. Okay, so this thing is still there, right? It was not removed from just now from question 1A. So what I do is I just go to post hoc. Can you see Tukey here? You click that and you press and you see significant level. If you want to change, you can change. By default, it is 0.05. Continue. Okay. Right. So now you will see, besides this, you will see the multiple comparison. If you still remember the word I use, multiple comparison in the slides, right? To understand why is there a difference. What causing the significant difference in the results here. Okay. So if you have seen that I am challenged and interested work causing a significant difference, right? So what actually happening inside? So you can use a post hoc test or Tukey test to understand how these different age groups mean are actually affecting the main result. So from here you can see the p values in the SIG column here. So based on this, what you can conclude is certain groups of age are actually significant. For example, all these are not significant. You can see they are not significant, but this is significant, right? So you can see 0.015. Okay, so the age group of 18 to 24 and 55 are older are significant. Okay, that means these two age groups, when comes to their responding to this question whether they are challenged and interested in their work, they do answer differently. Okay, these two groups, possible 18 to 24 they like, right? But 15, 5 or older might not like it. All right, so that's why there occur differences there. Okay, what else we can maybe, yeah, here 0.22. You can see between the age group of 25 to 34 and 55 and older. Also, you can see some significance. Other than that, none. So you can only see the younger group and the oldest group having some differences. So this is how you can explore further in detail by using post hoc Tukey, right? To understand the behavior between groups, right? What is causing the significance in the ANOVA. Okay. So, okay, now let me move on to question number 3. So question number 3 says you need to find out if there's any difference between the age group and their overall job satisfaction, right? So now it's the same thing like just now. Okay, it's just that now you have age groups with overall job satisfaction. Okay, so let me close this and then I open up analyze, compare means, one-way ANOVA, I reset. So now I have to look at difference between age group and the overall job satisfaction. So where's overall, how satisfied with job? I put it under dependent list. And then the age group under the factor. Okay. So I also can use Tukey here just to see, right, how they are, what is causing their significance. Okay. So this is the age group. Okay, this is significant, right, between the age group. So it shows us yes, it is significant. Okay, but what is causing the significance? You can look at the SIG values. Okay, so if you can see what is lesser than 0.05 is between these two groups, 18 to 24 and 55 or older. And then you have here 25 to 34 and 55 to older. And you have this group 35 to 44 and 55 and older. And you also have 18 to 45 to 54 to 55 and older. Looks like all the age group versus the 55 and older group actually produces a significant difference, okay, which has caused a significant difference in age groups and overall job satisfaction. Okay, so that's how you conclude them. Okay, so I move on to question 4. So question number 4 here says, Find if the means are significantly different for the statements below based on the positions. So now instead of age, we have positions as the depending the factor, sorry, the factors, okay? So let me go back to this, analyze, compare means, one way ANOVA, I reset. Okay, so let me look back. Okay, find different statements below. So the statements are, how satisfied are you? Let me look for it. How satisfied are you with the flexibility? How satisfied are you with the total compensation? And how do you feel compensation? Okay, these three here. And then they said position. So where is position? Position is here. Which best describes your position in your company? I choose as factor. Okay, I can still do a post hoc, true key, continue. Okay, okay, so I'll be able to see the ANOVA results, the significant one. Actually, when you double click this 0, 0, right, when it's very small value, when you double click, you can actually see the actual value. Okay, for example, you say I double click this, right? Sorry, yes, not double click, you just click one time and you will be able to see the value. Okay, so if you see the value of this 0, it's actually not 0. Okay, it's just that it's a very small 0, close to 0 value, which is equal to 0.000000111111215. Okay, so that is the value, it's very close to 0. So SPSS usually just put as 0.000. So but if you just move your cursor on top of it, you'll be able to see the actual value. It's actually 1.1215 E-7, which is also equivalent to 0.0000000111215. Okay, all right. So moving on, so this is significant. You want to see the multiple comparison, you can see which are the ones that are actually causing the significance, right? So you can see not many, this one, this group, which is the superior manager, okay, with the director, senior manager, and then you have here professional and director, senior manager. Okay, so basically it's about between senior managers and others and more, right? The one that is causing the significance. So you can see based on the values which are less than 0.05 in this column here. Okay, you can see here. Okay, so moving on for the last question, which says perform the same as 1, 2, and 3 based on their ethnicity. Okay, I think this one I won't go through. It's basically you have to do for the same 1, 2, and 3 post hoc test for the different overall job satisfaction, and also the other questions like this ones, right? A to J and overall job satisfaction. Use a post hoc key, and then instead of the age or gender just now, you choose ethnicity. Okay, so basically ethnicity goes when you do the analysis. Okay, so here basically your ethnicity goes here. What describes your ethnicity, that goes there, and you do the post hoc. Okay, and then press OK, then you get the results related to that. Okay, the various things. Okay, so that's all for ANOVA, right? So please try this. Okay, install your SPSS trial version if can, which is valid for 1 month, I think. Just to get a hands-on experience with SPSS, quite interesting as well, quite easy. Or you can use any tool. As we told you, there's no restriction on what tool you want to use, because even R programming or Python, you can, like R programming, they have built-in stats functions which you can always use, right? For t-test they have, for correlation computation they have. Okay, even Excel actually you can use for data, but if I'm not mistaken, multiple comparison, it's not that easy to do with Excel. Okay, so anyway, give it a try. There are many other freewares as well. Please feel free to explore any tools, as long as you understand the concept, why we use ANOVA, why we use t-test, and how to explain the results to make conclusions that are meaningful. Okay, so thank you. All right, bye. So hold on, yeah. So some of you already started asking questions. So myself, I just start the session. Okay, let me see where I can record. Okay, can you all hear me? Can someone say yes?
Yes, doctor.
Okay, so let me take your questions here at the chat box. Okay, so you asked me whether do we have to set same critical value for all tests or they can differ. Okay, by default, the critical value, I think what you're referring to is the alpha value, right? So by default, we usually take set as 95% confidence level. Okay, so when you say 95% confidence level, so that makes it to 0.05 critical value. Okay, so by default you can use that, but of course you can set different values. But if I were you, what I will try to do is to test and see at which critical value maybe the p-value can reject the null hypothesis. Just an exploration, right? So to understand, is it logic for you to reduce the critical value so low, right, in order to be able to reject the null hypothesis? And how does it affect if you reduce the critical value so low that it helps you to reject the null hypothesis, but what is the disadvantages and advantages by you doing so, right? So you can discuss on from that angle. Okay, but to answer that, of course, it's not a must you must follow the same critical value. Different hypotheses can have different critical value. Okay, if the situation is not that critical, you can reduce you can reduce the confidence level. Okay, so when you reduce the confidence level, your critical value will increase. Okay, did I answer your question? All
Yes,
right.
doctor. Thank you.
Okay. Did you all manage to see the slides for lecture, the online lecture for inferential statistics?
Yes.
Okay.
Yes.
You can even have, if you want to ask any questions related to that, also you can ask here. And tutorial, I actually already gave the solution in the pre-recorded, which I already uploaded in Spectrum, but I did not put in Teams. Okay, I did not put in Teams because I'm meeting you all today. So after I meet you all today, then I can put the link in Teams as well. Okay. Okay, any questions for the lecture and the tutorial? Humaira, I can hear background. Okay, thank you. All right. Any questions? How's your group project?
Still collecting respondents' data.
Okay. Anyone already passed that part and already keying in data in the system? And may I know what are the tools are you using? Anyone using SPSS?
Yeah.
Yes.
In Amul, you're raising hand. Do you want to ask anything? Okay.
No, doctor, my mouse is problematic.
Oh, right. Okay. So who's using SPSS here, or any other tools you're using other than SPSS?
Doctor, I'm using R.
You're using R. Okay.
Yeah.
So even in R, you can call the built-in functions like the for t-test.
Yeah.
Okay, they have easily you can call those function t-test, and also for the correlation coefficient, it's quite easy to do in R as well. So
I'm just like cleaning the data now. I mean that was.
you already got the data.
Yeah.
Okay, so the concept will be still the same, in R. When you call the function, you send in the parameters in R programming. It will also generate for you p-value. Okay, you can actually use the help function to see how to read the parameters from the results that generated by each function in the R. Okay, and then you can take the p-value and you can do the same way like how we do in SPSS as well. Because hypothesis, you are writing it separately, right? You're not using a tool to keep your hypothesis. Hypothesis, you are documenting somewhere. And then as you use any tools to produce the p-value, then you can make conclusions in terms of accepting or rejecting your hypothesis. Anyone using SPSS or anyone managed to install the trial version? Is everything okay?
Yes.
Any problem? Kishore, did you install?
Yes, I have just installed and used it. Yeah, it's good. No problem.
Did you try the tutorial 8 with SPSS trial version?
Yes.
Did it work?
Yes.
Okay, that's great. That means it's not a limited version, right? You can still use the functions.
Yes.
All right, that's awesome. Okay, so you can try the trial versions. Okay, as I mentioned, I think you can, if you install now, you can easily use for 1 month. Isn't it, Kishore? Is it 1 month?
Yes, 30 days.
So it's enough actually for you. If not, in your group, I suggest that you take turns in terms of maybe if 4 of you in a group, 2 people install first, and then after it expires, another 2 members can install, or you do a group study, right, together, so that you have the license at least for 2 months. Okay, right, let me see the question. Doctor, is it the IBM SPSS statistic program? Lian, what are you asking actually? If you want to install, you can go to this link, the one I'm sharing in the chat box. We are using version 26, if I'm not mistaken. Okay, who in this class has tried tutorial 8? How many of you? Okay, if not, okay, you can, I will just open up my IBM SPSS if you want to have a look. So you got no other questions?
Doctor, may I know how to identify dependent and independent variable as mentioned by Dr. Hu?
For which part is this? T-test, is it?
Not really sure. When we try to figure out the hypothesis, Dr. Hu keep insist on want to find the dependent independent variable, but our group not sure how to do that actually. So we need clarification from Dr.
Dependent and independent. Okay. See, I do not want to confuse by giving a different explanation from Dr. Hu.
Tutorial 2. Group 2.
Okay. All right, because there might be certain things that has been that he might be referring to, which I might not be aware of. All right. So is it all right if you please check with him? Exact question you asked me. You have a way to contact him.
Yeah, sure.
Yes, so please do ask him as well. But trying to explain, but please don't take my answer as what I say, because I'm not sure he's coming from which perspective. Okay. So please check with him. Okay, again, what was your question just now? Let me see if I can figure out what is it about. What is the difference?
When we figure out like making a new hypothesis, then we should identify the independent and dependent variable, is it?
Because, okay, for me, I will put it simply like this, all right? What I tell my students is when you come up with a hypothesis, basically, okay, you want to find the relationship between 2 different factors. Usually, you want to try to see whether one variable is related to another variable, right? So in this case, we call a variable or factors, okay? So for example, gender. Gender is one variable, and maybe satisfaction on a job, okay, is another variable. So you want to see whether there is some kind of connection, or if one is influenced by another, in this case, gender and the job satisfaction. Okay, so as long as you have 2 variables here, that is fine in hypothesis, because when you write in your hypothesis, you do not really write independent or dependent variable. Okay, but if you look at my tutorial explanation, there is a question on variables which are dependent and independent. Okay, usually variables such as, for example, gender, right? So we like to see, okay, how one factor is influenced by the gender factor. Okay, so you want to see the relationship with how is job is considered as dependent and the gender here is independent. So how does job satisfaction depends on the gender factor. Okay, another factor which is I will also can say as independent in this case will be like age groups, right? Gender and age group. That's why if you see in my tutorial, I think question number, let me refer to the question here. Just give me a moment. I will see if I can open up the SPSS. Let me share my screen here. Okay, but meanwhile, let me see. I'm still confused where to download it. The link you sent has multiple programs to download. Okay, Kishore, if you don't mind, can you help your friends here? Can you share the link where they can download the install the trial version, please? Okay, meanwhile, I will check on Anova. Okay, thanks. All right, let me share my screen. Okay. Can you see my screen?
Yes, doctor.
Yes, doctor.
Can you see the SPSS?
Yes.
Okay. All right. So if you see, if I go to the only place I will see the dependent and the grouping is when you do Anova test, right? So if you go analyze, compare means, right? This is where for tutorial 8 later on you will use for to do the t-test, independent sample t-test and Anova. Okay. So if you go to Anova, okay, if you still remember, Anova we use when we are comparing more than 2 factors, okay, or more than 2 mean, right? So in this case, there is something called dependent list and the factor. Okay, so here, for example, job satisfaction, just say overall, how satisfied are you with your job? Okay, and then I want to see the relationship with a factor. This factor can be more than one, you know, for example, gender. If I put here as gender, so you have 2 factors here actually, which is male, female, and how it is affected with relates with how satisfied are they with their job, right? Sorry, hold on, yeah. Analyze, compare means Anova. Okay, let me do the post hoc. Okay, do you know what is Tukey?
Language.
Do you know what is Tukey? T-U-K-E-Y? Okay, if you have followed my lecture slides, okay, in my presentation, I mentioned that in one t-test, for example, when you're doing a two-tailed t-test, you won't know whether a mean, okay, you know that if you reject a null hypothesis, that you are actually rejecting a null hypothesis and there is significant difference between 2 different means, okay? But you don't know whether which factors are actually causing that difference within this fact, for example, in gender or the age group. So to know more detail on what actually affecting the significance, you can actually do multiple comparison, okay? So multiple comparison will look at various levels. That means it won't only say, okay, whether gender is significant with satisfaction of job or not. But instead of that, if you use Tukey, it will also show by gender. That means how does the male group relates to the how satisfied are they with job, and how does the female group also related to in terms of the satisfaction with the job. For example, if I put post hoc and I click 2 key, okay, the significance level I leave it as 0.05. You can change here if you want to. Okay, so now I will have, okay, I'm having an issue here. Actually, it's supposed to have more results because I'm also connected to VPN, you know. That is why I was a bit worried to do online SPSS actually, because I'm connected to PTM through VPN and I expected that it might not work as well because I'm online here, both Teams and SPSS. Let me try again. Anova, post hoc, continue. Not getting the results. Okay, let's try this age group. Maybe there's a. I'll try age group as a factor. Post hoc, 2 key, continue. All right. This is much more, I think the data that I chose is not related. Okay. So here, if I go by age group, if I use 2 key, then I will get this multiple comparison. So you can see my SPSS screen. Just double checking with you all. Ken?
Yes, doctor.
Okay. So the multiple comparison here will show you like this is SIG column is the column you have to refer to check for p-value. Okay. So when you do 2 key, it will show you for every combination of age group whether it is significant or not. So if I use 0.05 is as my critical value, then 18, 24 versus 55 and older is a significant group. So possibly, okay, this is the first table actually shows the overall significance. Okay, that means it shows that whether the age group is significantly different or not for in terms of age group for the job satisfaction. So here you, because of these results is 0.02, you have to reject the null hypothesis. And then you accept that yes, the both means are not the same. That means one is affected by the other, right? So to know more in detail what is actually happening within the group and between the groups for ANOVA, you can use 2 key, right? And then you can make further conclusion by looking at the individual p-values here. So look at which pairs of age group actually have which are actually significantly different. Okay, like in this case, this one 18, 24 to 55 older, 25 to 34 and 55 older. That means all the age group versus the oldest age group, which is 55 older, are significantly different. Okay, that means there is some kind of observation that we can see here. The job satisfaction of the people who are at the age of 55 and older are totally different with the way expressed by other age groups, which is 18 to 24, 25 to 34, 35 to 44, and 45 to 54. The way they express on job satisfaction is different compared to this group of people, which is 55 and older. Okay, so that is how you can make conclusion based on multiple comparison. Okay, so do you understand any questions on this one, Anova? Or where to find the p-values?
So, doctor, for determining where which we want to choose, whether it's null hypothesis or alternative hypothesis, that means we are just depend on the p-value, right? It's not more defining our means to be less than perhaps like less than 100, then we accept null hypothesis. But when it's more than 100, it's not like that, right?
Your question is you are asking whether how to reject a null hypothesis, is it?
Yeah.
Okay, simple. All right, I will just make it simple for you. Just generate a p-value. Okay, actually there are two ways, you know. Either you can look at the statistic value depending, for example, t-test, the statistic value is called t-statistic. Okay, for ANOVA it is called F statistics. Okay, they are the higher it is, you can reject the null hypothesis. But if I can put it in a different way, okay, you can look at that statistic value to reject or accept null hypothesis. Another approach is to look at p value. So if I, like for my tutorial groups, I've been expressing to focus on p value. All right, that means once you have a p value, because all your tools can generate p value, right? So once the p value you know for that particular test, if that p value is lesser than your critical value, you reject the null hypothesis. Simple. Okay, so what is your critical value? Most of you will set your critical value as 0.05 because your confidence level you set as 95%. So what is confidence level of 95% mean? Okay, confidence level 95% means if I do that particular test 100 times, 5 times I might have wrongly rejected the null hypothesis. Okay, that means that might have just happened. Okay, that means the confidence I have in terms of like if you say 99%, that means out of 100 trials, at least one time I would have wrongly rejected the null hypothesis. So what it means is the higher your confidence level is, actually it is more difficult for you to reject the null hypothesis. Because you need more data basically to support a rejection of a claim. So that is why by default we normally use 95%. All right, unless for exploration purpose, I would suggest you set any value. So if you set 99%, then your critical value becomes 0.0. If you set 90%, then your critical value becomes 0.1. If you have 100% confidence level, your critical value will become, right? So do you understand that part?
Yeah, so means if we define the confidence, the higher that the confidence level that we define, that means the higher chance of the null hypothesis will be rejected, right?
No.
No.
Lower. You know why? If you set your I open up a Word file. You can still see my screen?
It is SPSS.
Word file?
I can only see the SPSS.
Yeah, I'm wondering why, because I am sharing a screen. Let me hide. Okay, now it went off, right? Still SPSS. Okay, let me see whether I can use this or not. How about now?
Yeah, it's okay.
You can see my Word file?
Yes, yes.
I just want to write down, you want to use this as my whiteboard, okay? So if I choose, so if your CL is 95%, your critical value, or also you can call it as alpha value, right? It's the same, will be 0.05, okay? All right. If I put my CL is just say 80%, okay, wait, 9%, just say. So my alpha value now goes to 0.01. Okay. Logic, I mean, reject your null hypothesis. You reject null hypothesis when p value is smaller than your alpha value, correct? Correct? Okay. So hello? Are you all there?
Yes, doctor.
Yes, we can
Yeah.
hear.
Sorry, I'm not sure. I think I'm having a bad network. Okay, sorry. All right. So if you can see, if my default is 95%, okay, critical value is 0.0. If my confidence level is 99%, my alpha value is 0.01. This you know, right? Minus 0.99 and 1 minus 0.95. Are you all there? I think I will. Hello?
Yes, we
No,
can
I
hear
think
you.
I'm having a bad network.
Doctor is
Let
quite
me.
doctor is quite laggy. Your voice.
Yes,
Yes.
yes. I can see. Let me get rid of my VPN first. I disconnect my VPN, so I can't use my SPSS. Right. I hope it will be better after that. Okay, you can hear me now?
Yes.
Yes.
Because I just canceled my net VPN connection. No, it looks like it's still bad. God. Can you all please respond to me, because I'm not sure whether it's okay or not.
Okay, doctor. It is okay now.
It's okay, right?
Yeah.
Really? Okay. So do you all understand how I get my critical value? How do I get 0.05? It's basically 1 minus 0.95. So this critical value 0.01 is 1 minus 0.99. So if I have 80% critical level, what will be my alpha value?
0.2.
0.2.
Yes, 0.2. Okay. So you just 1 minus the percentage. All right. So when we reject null hypothesis, we reject null hypothesis when the p-value is lesser than the alpha value. Okay. So if your alpha value is 0. Okay, when it is easier to reject? When it's 0.05 or 0.01?
0.01.
No, it's easier to reject when you is less than 0.05. This is smaller, all right? Because p-values that you generate usually they are large values, okay? Unless you have enough data and enough how to say data that can convince towards certain relationship in the two variables, you will get a p-value which is very low. It is very difficult for you to get a low p-value. Okay, it's not easy to get low p-value if we have done the proper survey. Okay, I'm not sure how it's for this class, because I know you all have limited time to get a lot of large data set, but in real life, when you do a lot of data gathering and you actually get a very normalized data, it is very difficult to get small. Okay, so that is why when you increase the confidence level, when your alpha level becomes smaller, it is even much more difficult to reject a null hypothesis, because you cannot get a very small p-value unless your data is really convincing that it can generate. You can try and see, all right? Do you really get that small p-values? Even through the tutorial that we have done, not many have less p-value. Like just now, right? I tried the job satisfaction against the group. Did you see? Hi guys. Having a real bad network. Are you all there?
Yes, doctor.
Yes,
You're
yes.
lagging.
It's lagging, is it?
Yes, slightly. Yes.
Okay. Did you all hear anything I said about the critical value and the p-value and all?
Yes.
Okay. Where did I okay. Because seriously, I don't know whether I was okay just now or not, the line. Okay, so the thing is, difficult to get small p-value. Okay, that is why it is difficult to reject null hypothesis if your confidence level is high. Okay, that is why in for example, when you do experiments related to just say medication or vaccine or something like that, it is logical to have a high confidence level, right? Because you don't want to reject a null hypothesis with a very low confidence level, because you want to make sure that you are rejecting a null hypothesis not by chance. So even better if it is 99.99%. It's even more difficult for you to reject that null hypothesis because the alpha value will be very close to 0. Okay, so that is considered perfect, right? That means it is not by chance. Okay, so that is why I'm saying if confidence level is high, your alpha is small. When your alpha value becomes small, it is much more difficult for p-value to be, I mean, the null hypothesis to be rejected, because it is not easy to get a small p-value. It all depends on your data that you have collected. Mean that you have to manipulate your data, okay? Because rejecting a hypothesis does not makes, doesn't mean that it's good, right? It just you're trying to make some conclusion out of your data that you got, right? So you don't have to try to reject null hypothesis every time. There is no good and wrong about it, right? If you cannot reject, that means you can't reject, right? That means that's what your data says. You cannot assume anything because you can't reject. Right, so don't try to reject a null hypothesis, okay? Because by rejecting is not, it doesn't mean that it's correct, right? What is important here is you know why we are rejecting and why sometimes you can't reject, why sometimes the p-value is small, why most of the time the p-value is not small, right? If you do the tutorial aid, you will see that not always the p-value is lesser than 0.05. Most of the time it will be more than that, okay? So if the situation is such, I mean, the data you collected can be, maybe it's not large enough, okay? Or the truth is that, right? I mean, there is no significant difference. So that is why your p-value is big, right? So this can be all the conclusions that you can make. So don't try to force yourself to reject null hypothesis. I even had a group who did not reject any null hypothesis. That is fine, right? Because that means there is no significant relationship in the factors that you were studying, right? That is also a finding. Okay. So did I clarify on that? What is 60%?
Doctor, should we come up with multiple alternative hypotheses, or just one alternative hypothesis is enough for our assignment?
I think for your assignment, just stick with one alternative. That means for every test you want to do, just have one null, one alternative. Okay, you can have many hypotheses, but every hypothesis just have one set of one null and one alternative. Okay.
All right. That means our alternative may be like maybe the null hypothesis say yes, it will like that, and then our alternative say no, it's not like that, something like that, right? It's
Yes.
binary value, something like 1 and 0 only.
Yes, because your alternative usually, okay. Please understand what is null hypothesis. Null hypothesis is always says that, okay, null hypothesis, for example, if I tell you what is the percentage and male and female in this world, what will your answer be? What is the percentage of male and female in this world? What would your answer be?
Male?
No, the percentage. Male 50%, female 50%, right?
Yes.
That is a common understanding, correct? All right. So this, okay, your null hypothesis is something like that, you know. Your null usually will be something that has not been proven or something that has been accepted commonly. Usually that is how null hypothesis is. Okay, something that has not been proven or something that is accepted commonly. So for example, like the claim is in this case, the gender, they are 50% male and 50% female. That always has to be a null hypothesis because it is something accepted commonly, right? But in your case, for your testing, you will have a lot of null hypotheses which you don't know the results yet. For example, you want to study what is the relationship of gender and the the preference to the type of social media app that they use. Just say, I don't know. Many of them might not even know unless you have done some kind of literature study or research from papers that says, oh, female like to use Facebook more than men, something like that. Then you can put that as your null. But if not, you assume that there is no difference in terms of preference to social media app, regardless of what gender they are. Okay, so that will be null because you have not proven anything. But your alternative will be, yes, there is a significant difference. Okay, so now you're trying to prove whether can reject that null hypothesis or not. Your data that you collected for that particular study will be able to reject that particular null hypothesis if you have, of course, enough powerful data that supports that claim. Okay, but if it doesn't, then you have to accept that no, there is no difference in terms of gender. They both like similar kind of apps. Okay, so that is the conclusion you make. So null always will be something that is commonly accepted or something that you have not tested and you want to test. And always you assume the means are equal. They are equal. There is no significant difference between them. Okay?
Right, thank you, Doctor.
Okay. Actually, we have another 20 minutes to go because yeah, if you have other classes, you can leave, no problem. I'll just stay until you have any queries, you can ask. I actually stopped my SPSS because when I'm connected to VPN, it's even slower, my network, right? So sorry, I can't open my SPSS, but I hope you can go through the slide, the pre-recorded slides, which I actually screenshot my whole SPSS step by step for all the questions. Okay, so please go through it because that will be very, if you're using SPSS or even if you're not, the concept or the idea will help you to process your data and make conclusion, right? What you go through in tutorial 8 and tutorial 9 is what you can apply with your own data. Okay. All right, anything else?
Doctor, I would like to ask regarding the project. Can I present my screen?
Can.
All right, Doctor, so this is our report. So I just want to make sure whether we are on the correct path or not. So this is our introduction.
Okay.
And our problem statement.
Okay. We gave a limitation of pages, right?
Yes, I guess, but I don't remember it.
Yeah, I think 10 or something. All right. Okay, go ahead.
Okay, so I just want to ask whether is this the way of writing objectives?
Can to determine, okay, you can have to determine, can I suggest that you have a mixture of measurable terms there, like everything is to determine, right? So maybe you can put like to understand, actually what you want to determine the impact of social media on self-confidence. Okay, can I discuss that later on? Because I suggest that the objectives, you better have a mixture of different verbs, you know. Usually when you do an objective for a study, you can start off with maybe first to measure, to formulate something, or to investigate, or to understand, right? Because I feel here, I just want you to try more than just determine lah. Okay, can you try to figure out other verbs which are suitable for objective? Okay, because there are more things that you can write other than determine. Okay, all right. Okay, you just I'm sure you can, because there are so many other words that you can actually put there. But the concept is fine, all right? I mean, you want to see the, you can even put like this, to understand the relationship between prevalence. Is there two things there? Which one does you want to understand? Okay, to understand the relationship of the impact of social media on students' mental well-being. Okay, you can write like that for statistics, because you want to look at the relationship between these two different factors.
Yes.
Okay, all right.
And this is our research method.
Okay.
Yes, it's quite lengthy. And our research question.
Yeah, I'm actually a bit worried because already page 4 or 5, but we have not seen the results yet. So, there might be, you might need to reduce certain things, especially the lengthy text, because I'm afraid you might not be able to put in your tables or your graphs. Okay, so later on, please check whether it's enough or not, right? Okay, go down, see the hypothesis.
Our research questions.
Okay, how?
Correct.
What is the correlation between? Yeah, this one is all right. The hypothesis.
This one.
Okay, because I don't want to go through every single thing here, right? I cannot be like, comment here. Maybe that one you can PM me later, all right? If you all want me to check or anything, you can just send me. But I just want to roughly give some suggestions so that all of them can get some idea. How many hypotheses you have?
For now, we just have listed 4. I mean 2 here. But there are gonna be more.
Okay, when you all are deciding on the hypothesis, you see, you might be doing more than just 4 or 5 hypotheses, like previously some students, they did 20 tests, 30 different tests, but at the end of the day, they picked up the tests that they liked and the ones that are interesting to put in their report and presentation. That is how it's going to be, you cannot fix now itself what you want to present, right? Until you get all your data and the results, right? So the interesting ones which you think can put in and make some sense and make some interesting conclusion, I suggest you put those hypotheses in. Okay, maybe there might be 6 like that, 5 or 6 hypotheses, but try to focus more on the results. And if because even in methodology, right, if you all can do some kind of short points or something, that is fine, no need to write a long text. Okay, because research method, sometimes you even can draw, illustrate in a diagram as well. Okay, which is much interesting to see instead of reading the whole text. Okay, but keep it simple, right? Don't write too lengthy of a research method. I think your research method is a bit long and it's very texty, right? So don't have too much of text. Try to put in points form, which will be much easier to see. Okay, how many respondents? How did you do the sampling? Focus more on those things than explaining very detailed like that, because you can always explain in your presentation. Okay, so try to put points and you explain in presentation. Okay, so the hypothesis, you just put in the null and alternative hypothesis for every every test that you have chosen to put in the report. Okay, or the one that you want to present. If you have done 30 hypotheses, you don't need to write all 30 here. Okay, you just pick the ones that are interesting, the ones that will answer your objective, and that you put it here. Okay, but if you suddenly find something is interesting but it's not in your objective now, then feel free to change your objective. Okay, because sometimes you just don't realize, you do the things and then you realize that there are much more interesting factors and relationship in a different area that maybe you just coincidentally found through your exploration. Then you can rectify, you can refine your objective, or you just add on.
Right.
Okay, all right, then
I'd like to ask, in our survey we just asked for the students' weight and height, so we have to compute the BMI. So later in the SPSS we have to create another column of BMI, right?
Yes.
So is there any way for is there any built-in function for the SPSS to automatically calculate BMI for every student?
No, not like that. You have to create your own the column, and then you have to create the equation to calculate maybe from the various cells.
Oh,
Okay, you create, basically you're creating a new variable. I think this one you will be able to figure out yourself. Okay, you just check out and see, because as this is a new variable creation, right?
Yes.
It's either you create them in a different software, you get the data and then you transfer them to SPSS. If you find Excel is easier, okay, you can always calculate things in Excel and then transfer the data into SPSS. You can do that as well. You know, some of the students, what they do, they transfer all to Excel first. They do all the columns that they want and then they import to SPSS. You can do that as well. Okay, because sometimes Excel is much easier to compute new variables from various other variables. Correct?
I think
Yeah,
that's
but
all.
you can try in SPSS itself if you like.
I'll do some research on that
Okay.
later.
All right.
Thank you, Doctor.
Okay. Anyone else want to share and want to ask anything?
Doctor, I have a question.
Yes.
In my project, I have a hypothesis is about gender and what will they do while eating the food, such as talk to others or watch video, television, something like that. And then my null hypothesis can write like gender does not affect what the person does while eating food. Can I write like this?
You can write more like this. There is no relationship between gender and the I don't know what is the second one. You can write there is no relationship, or there is no, you can do like this. There is no relationship between gender and the other one, whatever you say just now, what they do while they're eating, right? Or
Yeah.
you can say there is no significant difference between gender and whatever the other one. So you can, usually we use like that. There is no relationship or there is no significant difference. Both means the same.
Oh, okay. Understand.
That will be better than if you write gender does not affect. Now, I think you stick with there is no relationship or there is no significant difference between.
Okay.
Okay.
Doctor, like this question, like for the what they do while eating food, so there's no the the statistic like 1, 2, 3, because the response we collected is like eat quietly and then how many percent and then talk to others like this. So
It's qualitative kind.
yeah.
Okay, you see, Shanghai, right? Okay. The thing is, you know, for this kind of t-test and correlation coefficient kind of test, you better choose questions which are more to scale kind.
Okay.
The scale, yeah, those are the ones which we will be. That's why from early onwards, I was asking you all to have a lot of scale-based question. You know, the scale like 0, 1, 2, 3, 4. Those kind of questions is much more easier for you to analyze for t-test and the correlation coefficient later on, right? So do you have those kind of questions which are more suitable or not?
Yeah, I have
Yes.
other.
Yes,
This is
because those
what
are the
I
ones will be helpful in terms of doing statistical analysis, right? Because qualitative sometimes will be more like you can report in terms of descriptive, right? Percentages, the mean and things like that. But when it comes to t-test and correlation, regression, you have to use a lot of scale kind of questions. Because you see, even gender, unless you can do that, you know, for example, gender, what we do is we label them 1 and 2, correct?
Yeah.
Yeah, you can do that way if you want to try.
Okay. So doctor, for our project, is only inferential analysis can be used, right?
You can use. I don't get it actually. You can do descriptive. You can do inferential. You can do correlation coefficient. You can do regression.
Oh, okay.
Yes, that is why I ask you all to really try the tutorial. You know why? As long as you can do this tutorial, you will understand how a data can be used to analyze and come up with some conclusion to understand the relationship. The next class, okay, next week you all have midterm, right? After that, in week 10, I will be doing the same thing like this, you know, the pre-recording for correlation coefficient. I will have the recording, but I'll have the online lecture as well, but I will have the pre-recording. and also for the tutorial as well. Okay, so when you look at this tutorial 8, tutorial 9, I hope that you apply that in your group project, because it is the same. That is what we want you to do as well. To try to do the significance testing, try to do the, the Tukey, the multiple comparison, which is inside the tutorial 8. Try that as well. Choose the most relevant or useful variables that can do Tukey test. Okay, and then the week after, when I do the correlation coefficient, which is topic 9, you do that as well. Correlation coefficient. Okay, we'll explain why we do correlation coefficient. I'll explain that in the lecture. Okay, I will try to upload that even earlier. Maybe next week itself I will upload for tutorial 9. So when we meet in week 10, we can discuss rather than I present everything. Okay, so I appreciate if you all read the online lecture and do try the tutorial before coming, right? That will be useful for our discussion actually. Okay, so as I mentioned to Sheng Hao just now, try everything, right? Until everything, all the topics that we have in our statistics part. Okay, which starting from descriptive statistics, inferential statistics, correlation coefficient, which we will be doing after this, which is the next class, correlation coefficient and regression. Okay, and the last one is actually non-parametrics. Okay, so if you non-parametrics, what is non-parametrics? Okay, now most of you are assuming that your data is normal, correct? You're assuming that it is normal. That is why you're using parametric test, because t-test, student t-test is actually a parametric test. We have another set of tests which is called non-parametrics. We use non-parametric tests. Okay, for example, Mann-Whitney. Mann-Whitney is a different test. Okay, so why we use non-parametric test is if we don't know whether our data is normal or not. Okay, most probably your data is not normal because your sample size is small, right? When your sample size is small, most probably your data might not be normal. But please go ahead and use parametric, although it is not normal, because we still want you to try to use parametric tests like student t-test, Kendall-Stau for correlation coefficient. Try using that. Okay, but you also can try using non-parametric tests, which is your last chapter actually, which will be covered by Dr. Ho. But even now you can go and have a look. What is parametric test? What is non-parametric test? Okay, why do we use parametric test and why we do use non-parametric? But to keep it simple, one is because the data is normal. The other one is because the data is not normal. Although your data is not normal, please go ahead and try parametric because it is important for you to know. Okay, but it's no harm in you trying both parametric and non-parametric to see whether the null hypothesis is rejected or not. Okay, for example, just say you have a null hypothesis and an alternate hypothesis. You're using t-test to see the significant difference. You can have another test to do the same thing under non-parametric test. Okay, go and find out what is a similar test like t-test, but that is considered as non-parametric. You can try that test as well. That is also available in SPSS. Okay, or any R programming. Everything will be there. Just Google and see there two, parametric, non-parametric. What are the sample tests? Try both. Okay, you will see why is one can reject null or the other one cannot reject null. Okay, but the concept is normally the non-parametric is less sensitive compared to parametric because non-parametric assumes that we don't know much about the data. Okay, and the data is very small. So possible we will get a different results when you use non-parametric. Okay, so try everything, right? I told my tutorial group, Sheng, how are you from my group?
No, doctor, I am from group 1.
Okay. So because I was telling my group that I want them to do all the tests, right? Until the last one, which is maximum you can do. Okay, the least you should do at least until correlation coefficient and regression. Okay, if you can do more, you can try non-parametric. Okay, you see how.
Okay, doctor, thank you.
All right. Please check back with Dr. Hu as well. He might have some other instructions, right? So please always refer back to your tutorial lecturer because they are the one will be marking your project. Okay. So especially those who are under Doctor Who, always check back with him. Okay. All right. Anything else?
Doctor.
Yes.
For the questions because we in the form we got an open.
I lost you. I lost you, Jasun. Hello? Can you all hear me?
Oh,
Yes,
sorry, Doctor.
Doctor, we can hear you.
Okay, Jasun, I can't hear you actually.
Yeah, just now I disconnected.
All right, okay. What you were saying?
Because in the questions we got an open-ended questions and we face difficulty when we want to put the result into SPSS. So what should we do?
You see, open-ended question usually we don't analyze using SPSS. Okay.
Yeah.
So open-ended question, I hope you didn't have too much open-ended question, right? Because analysis usually quantitative we use SPSS is for those with quantitative values, right? Like you can use the scale kind of questions and even the descriptive kind of things you can do in SPSS. But if open-ended, what I suggest you to do is, for example, when you are just say rejecting or accepting some kind of null hypothesis, you want to support that finding, you can use your open-ended questions. That's how we normally use, because unless you have the time to process the open-ended question, because there's another way of encrypting the open-ended question. You can categorize them. You can categorize what is the conclusion from the open-ended question. Okay, but if you don't have enough time, I suggest that you use your open-ended question to support your quantitative analysis. Okay, that means, for example, you'll have few hypotheses that you accept or not accept and all, right? Then maybe, okay, just you see that, oh, this null hypothesis cannot be rejected. Okay, but then you can go to your individual open-ended questions to figure out why is it so. Can you get some outcome from there or not? What they say, right? So if that kind of question can support your quantitative conclusion, you can use that. So it's basically to support, right? But if you really want to analyze them, but that is a different topic altogether. You have to do an analysis using NVivo and things like that to do scripting for open-ended questions under statistics. Okay, that doesn't involve quantitative usually.
Okay, thank you, Doctor.
All right. Okay, anything else? Any other questions? You can chat as well. Write your question in your chat box. I can answer. Okay, so please, okay, I will officially end the class here, but I will just stay on just to see if I'm getting any questions, okay, in the chat box. So if you need to leave, you leave, because you might have other classes. By next week, I will try to share by next week, okay, if possible, I'll try to share chapter 9. Okay, the reason I want to finish earlier is so that you also can use that for your group project, okay, because I believe these tutorials will be helpful for your group project. At the same time, I do not want to have online face-to-face class during New Year Eve and Christmas, all right? So I'm sure all of you also need time for that. So because it's actually scheduled during that time, correct? Our face-to-face. It's New Year Eve and Christmas time. So it's okay, we try to bring it much earlier, the face-to-face classes, because it is also helpful for your group project. Okay. So yeah, so if you have nothing, I will end the class here. I will just stay on maybe for another 10-15 minutes to see any questions. You can in the chat box or what. Okay, so thank you very much. Okay. Okay, so any information, please keep checking Spectrum. Okay, and also please check Teams as well for any meetings that I want to do online. Okay, thank you very much.
Thank you, Doctor.
Thank you. I will just stay here for another 10-15 minutes. Okay, if you have any question, you can just ask me.